Welcome all. Now we will see a general balance equation. So in order to perform the material balance calculation, we require general balance equation. Since we know that there are various processes, various or different types of processes, suppose batch process, continuous process, semi-batch process, and all these processes may be operating at different variable conditions. Okay, so a specific type of balance equation, okay, for calculating the material balance, a specific type of equation may be required for each of the processes that we have so far studied. Okay, so here initially what we will draw is the general balance equation, and later on we would try to relate this general balance equation to each of the processes that we have so far studied. Okay, so initially just think of it is a process, one process unit is there, and in this process unit input as a methane is entering into it, and similarly methane as an output is coming out of the system, that is leaving the system. Okay, so this is what a one of the process that is happening. So in order to understand exactly whether this process is going on as it has been expected, to understand that one, we can say that here that the mass flow rate of methane in both stream, that is in input as well as in output, if it is equal, then it's okay. If it is not equal, okay, if it is not equal, then what could be the chances? What could be the chances that we have to determine in order to put all this thing in making a general balance equation? Because what we have initially thought that input should be equal to output when there is no chemical reaction or when there is no reaction at all in the constituent that are coming into the process. Okay, but whenever there is a chemical reaction between the constituent that are coming into the process or process, then we can say that the general balance equation or the equation may be different. So here first of all what we are trying to learn is the general balance equation, and so here what we are assuming that the two possibilities, that is a chemical reaction may be taking place or a chemical reaction may not be taking place. Okay, so if this is the case, then what we get is the general balance equation, and whenever there is no chemical reaction at all, then the general balance equation would be different to what we have drawn, and the general balance equation would be different whenever there is no chemical reaction, suppose, or whenever there is a chemical reaction, the general balance equation may be different. So initially what we will try to learn is the find out the general balance equation. So here the methane enters, methane leaves, so we can say that there is one constituent, one component that enters and that leaves, so there is no chemical reaction. But in situations, suppose in certain situations there is a possibility, then what could happen if the amount of output that is coming from the process unit, okay, if it is not equal, or if it is not equal to what it is entering into the process, then in that situation we have to predict or determine what exactly has happened to the process unit, what exactly has happened in the process unit. Suppose you just think of that the input, that is input of methane, is not equal to output of methane, then in such a situation what could have caused this to happen? The first thing that we would like to find it out, that the methane may be consumed in the process, okay, may be consumed in the process as a reactant, or it may be generated as a product within the unit. Suppose the methane entering and the methane coming out. The methane, if it is entering, the amount is suppose some quantity, then the methane coming out of the system, suppose the amount is certain quantity. If this quantity, that is the output quantity, is more than the input quantity, in that case we can say that the methane is still generating in the process. If the methane quantity in the process is happen to be methane output quantity is happen to be less as compared to that of the methane input quantity, then in that case we can say that it could be consumed as a reactant in the process. So this may be the cause, okay, this may be the cause. why the amount of methane that is coming from or that is leaving the system or leaving the process unit is more or less. Okay, so this could be the reason we could justify over here. The next one is that suppose the amount of methane is coming out less, then we would say that the methane may be accumulating in the process unit or absorbing on the walls of the process unit. Okay, and that is why the methane quantity that is coming out as a output is less. Okay, so this is the another reason we could be able to, or we can specify over here. The next one is that suppose this process unit may be having certain leakage, so it may be leaking through that one. Methane, as it is a gas, it may leak through that pinholes that this process unit may have. Okay, this is another reason you can state over here. So sometimes this happens that whenever we are making the material balance calculation on the process unit, we may go wrong. Okay, so there may be some error, there may be some mistake that we perform while doing the material balance calculation, that also we cannot rule out. Okay, that also is possible and we cannot rule out. So all these reasons, 4 reasons, we take into consideration why the output is more or less as compared to the input. Okay, why the output is more or less as compared to the input. Taking into consideration all this fact, we make a general balance equation here right now. Okay, a general balance equation is here. It is input plus generation minus output minus consumption equals to accumulation. So all these predictions, all these analysis that we have taken, or all the assumptions that we have taken into consideration, why the methane that is coming out of the process is less as compared to the input, or why the amount of methane coming out of the process is more as compared to the input of the methane coming into the process unit. So we have taken these assumptions, we have taken into consideration all this fact, and finally what we come to draw one equation. That equation is input plus generation minus output minus consumption is equals to accumulation. Okay, now next is we want to just determine, whenever we want to perform material balance calculation, we use again 2 different types of balances. Okay, 2 different types of balances. The first one is the differential balance, and another one is the integral balance. Okay, so we will see one by one in detail what exactly is a differential balance. Okay, so differential balance, it indicates that what is happening in a system at an instant of time. Okay, differential balance, the first one, it indicates that the balance that indicates which is happening, what is happening in a system at an instant of time. Okay, at an instant of time. Okay, so just remember, or just look at it closely, that what is exactly happening at an instant of time. Okay, instant of time. So instant of time could be, suppose, second, minutes, hours. So you can say that, so any such process or any system in which a process is happening, one such process is happening in which you can see at an instant of time the changes are occurring in the changes are occurring in a system. Okay, changes are occurring in the system, or you can find the changes in the system at an instant of time. Okay, at an instant of time. That instant could be very short. Okay, so it may be in seconds, it may be in minutes. Okay, so such is happening, such thing is happening in the system, then often we use differential balance. Okay, we use the differential balance. So what this differential balance give us, this differential balance give us at the end what we say a balanced quantity. Okay, balanced quantity divided by its unit. That means we measure what is happening at an instant of time, taking into consideration that fact, the quantity that comes out divided by that instant of time. It may be a second, it may be a time, it may be minutes, it may be hours. Okay, so that instant of time must have to be divided to the quantity which we are just thinking of, or which we are just calculating, what we call this as a balanced quantity. Okay, that balanced quantity is divided by time unit. Okay, it may be seconds, suppose it may be minutes, whatever you can take. Okay, so depending upon that instant of time we have determined, and within in that instant of time what is happening in a system, okay, what is exactly happening in a system that we want to determine, or that we want to make a material balance calculation, then we use the differential balances. Okay, so again we would like to think of that differential balance is used to measure what is happening in a system at an instant of time. Okay, at an instant of time, and at the end what we get a balanced quantity. So this balanced quantity unit is, okay, the balanced quantity unit is, suppose we are here for finding out the mass of a certain substance that is entering and the mass of the substance that is coming out of the system. Okay, then that quantity is the mass. Okay, of course mass is coming out of the system, the quantity, that is the mass that is coming out of the system. So that is the balanced quantity. It may be having certain unit. For example, it may be determined as mole, kg, grams, or like such units may be used, but it also accompany as the instant of time, the time period for which the changes, the time period, in that time period what changes, the changes has taken place. Okay, that changes has taken place in a system. Okay, or the system has moved from that particular state to another state. Okay, so that change is a balanced quantity, that quantity, total quantity, divided by the unit of time. Okay, it may be second, instant of time, it may be taken, if instant of time is taken as second, or instant of time may be taken sometimes minutes, or may be taken as hours. So moles is that particular balanced quantity, that is here weight, okay, or the mass divided by the time unit. Okay, time unit. Now this differential balance, as the name instant, that instant of time is the basis for the calculation. Okay, instant of time is the basis for the calculation, and this is possible only when the process is going on continuous. Okay, process is a continuous process. Okay, process is continuous process. Then differential balance equation is mostly used when a continuous process is there. Okay, so this is very specific. The next one is the integral balance. What is the integral balance? Okay, so integral balance determines, okay, integral balance determine what is happening between two instant of time. Okay, what is happening between two instant of time in a system. Okay, between two instant of time, that is the instant of time may be the moment after the input takes place and the moment before the product is withdrawn. That means that what happened, the moment once the matter or the mass enter into the system, and before leaving the system, what exactly happened with the mass, what exactly happened with the mass in a system, that we want to determine here. Okay, that we want to determine. So this is the two instant of time. Between the two instant of time is the time period, or the basis of calculation here by can be done with the help of integral balance. So input, once the mass enter into the system, it remains in a system for a while, and then finally we take it out. So for how much longer that mass remains in a system and undergo certain process, so that it can change from that particular state to another final state, suppose. So once this happens, then only you take out the product. So between two instant of time, we have to make the material balance calculations. So the unit of, okay, whenever we are making the material balance calculation, the integral balance equation would have the unit as amount of balanced quantity. Suppose we are using taking input as the mass of a substance, or in kgs, or what we say grams, volume, moles, or likewise. If it is getting introduced in the system, then finally we get a output. So output is measured as the amount of balanced quantity. So there is no other unit of time. Okay, there is no other unit of time, because we are here determining the amount that is produced in a system when it has undergone certain process, then what is happening between two instant of time, that time period is taken in order to find it out exactly the amount of that particular total quantity, amount of that quantity. Okay, so amount, that is the substance undergo between the two instant of time, undergo change between two instant of time. Okay, between two instant of time, the substance undergo change between two instant of time. Okay, so integral balance are mostly used for batch processes. Okay, you can see here the integral balances are mostly used for batch processes. Okay, whenever there is a batch process, you know that in a batch process the material enters into the system, the mass get transferred into the system initially, it remains in a system for a while, it undergoes certain processes and it moves from one state to another state. Then that state, that is what we are expecting, is obtained. Then what we do, we take out all that substance from the all that mass from the that particular unit or batch process unit, and then this instant of time, okay, this instant of time, okay, the two instant of between two instant of time is actually possible in a batch process. Okay, actually possible, we can observe in the batch process only. It is not possible in a continuous process, because in a continuous process the instant of time is very less, in minutes, seconds or hours suppose. But here in batch process the time period is large. Okay, the constituent or the chemicals or the mass remain for a while, so between two instant of the two instant of time is large, and that's why we can say that the integral balances or integral balance is mostly preferred to make the material balance calculations on batch processes. Okay, batch processes. Now you have understood all the basic concept regarding what are the equations that we use for doing the material balance calculation. Moreover, directly switching to calculate the material balance calculations, we will first learn the few what we say fundamentals. That fundamental may be required in order to solve most of the material balance calculation. So here what we are going to see is the first problem that would help us to understand how a mass, how a mole fractions can be calculated and how to determine the percentage composition. Okay, so this preliminary understanding of the mathematical concept that may be continuously required in order to solve the material balances calculations. Okay, in order to do the material balance calculation. So initially we would see the basic concept and clear to ourselves how to solve, then resolve or solve these few concept. Okay, so here there is one problem we have taken. That problem is here: a stream contains 20 gram of oxygen gas, 70 gram of nitrogen, 5 gram of helium and 5 gram of hydrogen. So what we are asked to determine is the mass and mole fraction as well as mass and mole percent composition. So this has been asked to determine. Okay, so here the percentage is given. Okay, 20 gram of oxygen, 70 gram of nitrogen, 5 gram of helium and 5 gram of hydrogen. So total quantity is 100 gram. Okay, a stream that contains 100 gram, a gas stream that contains total weight is 100 grams suppose. So this stream is having different constituent as oxygen, nitrogen, helium and hydrogen. Now initially what we have to find out is the moles. Okay, moles. And what is mole? Mole is the amount of substance. Okay, amount of substance. So weight equal to its molecular weight is nothing but a mole. Okay, that is what we have to first determine, weight equal to its molecular weight. So here this is when weight equal to its molecular weight, it means that it is a 1 mole. Okay, so if it is given certain quantity of that particular constituent in mass, in terms of mass, then that particular mass to be divided by what we say, its molecular weight. So what we would get is the mole of that particular constituent in a stream. So here 20 gram of oxygen, it is the mass of that oxygen divided by its molecular weight. What we get here is the mole of that constituent. Okay, mole of that constituent. Similarly, we can calculate the moles of nitrogen, moles of helium, and moles of hydrogen by using the same equation. That is the amount of substance divided by its molecular weight. What we would get is the mole of that particular constituent in a stream. Okay, mole of that particular constituent in a stream. So 20 gram divided by 32, so mole of oxygen. So here then initially what we have to find out is the mass fraction. So to calculate the mass fraction, the given formula is here: mass component of the fraction. Okay, mass component of the fraction, that is one of the constituent present in a stream, divided by the total mass. Okay, this is the total mass. Okay, this is the total mass. So here you can find it out, the mass fraction of each of the constituent that comprises of this stream. Okay, that comprises of this stream. So mass component divided by total mass. So mass of oxygen is 20 divided by total mass, it is 100. So it comes out to be 0.2 as a mass fraction of that of oxygen in the stream. Similarly, you can calculate the mass fraction for each of the constituent making the stream. Okay, so this is 0.7 for nitrogen, and similarly 0.05 for helium and hydrogen. So this is a mass fraction. Okay, this is a mass fraction. Similarly, we can calculate the mole fraction. Okay, mole fraction formula: mole fraction is equal to moles of component, that is any component over here, divided by total moles. So here the moles already we have calculated. This is 0.625 for oxygen. So total moles we have make a summation of all these moles of the moles, it comes out to be 6.875. so the total moles 6.875. so mole of one component, that is oxygen, divided by total moles. So mole fraction comes out to be 0.09 for oxygen. Similarly, we can use the same equation in order to calculate the mole fraction of nitrogen as well as helium and hydrogen. Okay, so this is the mole fraction of constituent that comprise a stream. So here the fraction, okay, all those fractions as mass fraction, mole fraction, when you sum up it, okay, when you add all this mass fraction, then it must come out to be equal to 1. Similarly, mole fraction, when you sum up all this mole fraction, it also comes out to be equal to 1. Here you can see this 0.2, 0.7, 0.05, 0.05, it always equate to 1. Okay, it equals to 1. Similarly here also it also equate to 1. Again, what we have been asked to find it out the percentage composition. Okay, percentage composition. So percentage mass fraction can be calculated by multiplying what fraction, the fraction multiplied by 100. So what you would get is the percentage of that constituent. Okay, percentage of that constituent in a stream. Okay, percentage of that percentage of a individual constituent in a stream. For oxygen, suppose 0.2 was the mass fraction, multiplied by 100, what we get is the 20 mass percent of oxygen. Similarly, nitrogen 0.7 mass fraction multiplied by 100, what you get is the 70. That is, multiply the fraction. Okay, multiply this fraction by 100 to get the percentage composition. Okay, or we can say that in order to calculate the percentage composition, the fraction is multiplied, the particular fraction is multiplied by 100, so that what we get is the percentage composition. So herely we have calculated the percentage composition of each of the constituent comprising the stream. Similarly, we can calculate the percentage composition in terms of mole fraction, in terms of mole. So here percentage composition 0.09 mole fraction of nitrogen in a stream, multiply by 100, what we get is the 9 mole percent. Okay, 9 mole percent. So similarly for nitrogen, this was an oxygen. Similarly for nitrogen 36, and you can see over here for helium and hydrogen. So this mole fraction, okay, mole fraction, actually would like to let you know that the amount of oxygen 20 gram, while the amount of oxygen you can see here is 20 gram, while the amount of hydrogen was 5 gram, but the mole fraction, mole fraction also comes out to be less, but in terms of percentage, in terms of its percentage, it is of course more than the oxygen. You can see over here, see over here, you can see over here that the percentage of hydrogen, is more than the percentage of mole, 36 mole percent of hydrogen. That means mole percentage of hydrogen is more than the mole percent of oxygen, even though the amount of oxygen was more in a stream, but still the mole percent of hydrogen is more. And that is why this, we, in order to find it out, these things we require to perform these calculations. So without this calculation, or without doing this calculation, we cannot make a statement that by looking at the composition that this may be present in more fraction or this may be present in less fraction. So if when you calculate the percentage mole fraction and later on and subsequent percentage composition, you would see that the mole percent of hydrogen is more than that of a mole percent of oxygen, even though here the amount of oxygen in a stream is more. So this would be a contrast to what we have thought, and therefore these calculations initially must be performed in order to find out what constituent is present in more concentration. And moreover, these basic calculations are essentially required while doing the metal balance calculation, as we know that the unit process or unit inputs to the unit may be different, and their composition or their composition may be different. Moreover, the units may be different, and therefore we must be in a position to make the unit as homogeneous, to make the unit as homogeneous, or we can say that a similar unit must be we have to convert it into one and only one unit, all that composition that is entering or all that stream that is entering into the system, so that the calculations can be done, and finally we could come to the conclusion as a output that it would have one and only one unit. So the stream entering into the unit process may be different, and their what we say exact units unit may be given different. Some may be given in moles, some may be given in mass, or some may be given in kgs. Then we have to make one unit for making the metal balance calculation. That is, we have to make a unit similar, either in mole or either in kg. So that only then and then only we could be able to make the calculations properly. So that is why it is necessary to understand, first of all, before performing the metal balance calculation, that we must know the basics of calculations. Basics of calculation. That is why we have taken, or we have considered this for understanding while solving the future problems.